Hello guys, this is Sachin and this is going to be my first video. What basically I'm trying to do with this channel is record as many solutions as possible to the Leetcode questions, and the primary language that I'm going to be using is Python. So stick with me, let's see how far we go. Alright, so today's question will be maximum depth of a binary tree. That is the program statement that given a binary tree, find its maximum depth. The maximum depth is number of nodes along the longest path from the root node down to the farthest leaf node. So if you see in this given diagram, there could be two paths that lead to the longest depth, right? 3 to 15 as well as 3 to 7. So let's get into it. Let's I'll first try to code. Oh, yeah, just a minute. So I'll first try to code it and then we can discuss about it. So first of all, the base condition would be suppose we hit a null node, that is we hit the leaf node and there is nothing after the leaf node, right? The leaf node it will be none. The left node of the leaf will be none as well as the right node of the leaf will be none. So we can get to the point where if not root return 0, else what we will do is we will calculate the left subtree height as well as the right subtree height by using depth first search. And how that will work, I'll explain at the end of this code. Like we will first write the code and then I'll explain how it works. Left height equal to root dot left. So it will keep going to the left until it reaches, and then we will also calculate the right height. Self dot max depth root dot right. Then while returning, we will return 1 plus max of these two. I'll explain why. Okay, let's see if it is accepted or not. So 3 submit and it is accepted. So if you can see here, this is how the code will work. First, the 3 will be root. It will go to if not root return 0. Since 3 is a node, it won't return 0. It will go into else's part. Left height would be self maximum depth root dot left. It will go to 9. It will now it sees 9 is a root. So this will be our first recursion. So remember, in our first recursion we are calculating left height and root was 3 previously. Now root is 9 and we again do the left height. Now the root dot left is null, so it will return 0. It will return left height will become 0 for the root 9. So we will calculate right height for the root 9. Then the execution of the program will come here, and then we have root dot right, that is 9 dot right is nothing but none. It will go again here if not root and it will return 0. So now we have left height equal to 0 and right height equal to 0. If we didn't add 1 here, we will just be returning 0, and this will return 0 to 3. That is not correct, right? So we will return we will add +1. So this will show us that 9 has the maximum height of 1. 1 plus max of 0 will be returning 1, 2, the left height of 3. Remember at the first recursion we had the root as 3 and we were calculating its left height. Now it's time to go to right height. So now it will jump to right height equal to self dot. We already found the left height, right? Left height is 1. Now it will go to right height, and right height will go to root dot right. Root dot right is 20. It will go to 20. Then it will, now the root is 20. For 20 it will calculate the left height similar to the it was calculated for 9, and it would show that it is 1. So it will return 1 to 20. But since 20 has a right height as well, it will also calculate in similar manner. So both of these will return 1 to 20. Now 20 has left height of 1, right height of 1. It will return 1 plus max of 1 comma 1, that is 1, and it will return 2 to 3. Now 3 gets 2, and it will finally return maximum of left height we previously calculated 1 and right height 2. Max of 1 comma 2 is 2 plus 1, it will return 3. So this is how it works. Thank you guys, this was my first video. Let's Thank you so much.